In this question, we're told that a cinema manager believes that there is an association between the gender of his customers and the type of film that they've come to watch. The table below shows 1,000 viewers in his cinema, classified by gender and by the type of film that they watched. We're asked to use a chi-squared test at the 5% level of significance to investigate whether or not there's evidence to support his claim. So let's start with the hypotheses. H0 here says that there is no association between the gender and the film genre, so the two of them are independent from each other. And H1, there is actually an association between the gender and the film genre preference, so they are not independent. So those are our hypotheses. Let's get started. With a contingency table, if we don't have them already, we need to calculate the row totals and the column totals. So let's start there. We're going to need them to calculate any expected values. So starting with the top row, we get 564, and then we get 436. That gives a grand total of 1,000, which we were expecting. These column totals should also add up to 1,000, and if we just double check, we do get a total of 1,000. Now I'm going to calculate the expected by doing column total times row total divided by the grand total. So starting with action films that were viewed by male customers, I'm going to do 394 times 564 divided by 1,000. And that's where we get 222.216. Okay, a similar thing for each of the other cells, and just in red, these are the expected values next to the observed values. Okay, just have a quick look at whether or not these expecteds are far away from the observed values. That might give you some insight to the final result that we'll get. Now that we've got all of our observeds and expecteds, we can get on with the hypothesis test. Let's start with the critical value. So first I need to find the degrees of freedom. We have a 3 by 2 table. I'm going to subtract 1 from 3 to get 2, and subtract 1 from 2 to get 1. Degrees of freedom is 2 times 1. We have 2 degrees of freedom, and the significance level we were told in the question is 5%. So looking up the chi-squared critical value for 5% and 2 degrees of freedom, we get 5.991. On a diagram, any test statistic that comes out greater than 5.991 is going to be a significant result. Let's find our test statistic. I'm going to use the sum of observed squared over expected minus n. So I'm going to have the black number squared over the red number. So the observed 239 squared over the expected 222.216. And I'm going to do this for all 6 cells. Once we've got those all added together, I'm going to subtract the 1,000. That's our n value, the 1,000. And that leads to an answer of 5.572. So let's just check where that is. So it's actually on the left-hand side of the critical value, so it is not a significant result. Let's just formalize that. 5.572 is less than 5.991. This is not significant. As always, we're going to end with our 2 conclusions, one of them mathematical, and then the second in context. So my mathematical conclusion is there is not enough evidence to reject H0, and in context, we have enough evidence that there is no association between gender and musical preference. Those actually seem to be independent. This goes against the manager's claim. The manager thought there was a connection between them. The manager thought there was an association between them. Our hypothesis test says different.